Hello student, very good morning to all of you. How are you? I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think we were discussing about the glycoside halides or the bromide. Yesterday we have seen how the glycoside halide is utilized or used for the synthesis of the glycosides, because we are discussing the point is the synthesis of glycosides by using as a different starting material or the on the basis of glycosyl donor acceptor concept. And so far we have discussed about that trichloroacetamidates. Then second one is maybe as a glycols derivatives, and I think then glycoside halides or the bromide. With the some of the suitable example, we have considered how to prepare or how to synthesize glycoside halide starting from the pyranose cyclic ring of the D-glucose we have considered, and a glycol also glycols are the obtained or derived starting from the various starting from the pyranose ring and cyclic ring, and introducing their carbon-carbon double bond, and that derivative is called as a glycol, and from that we can synthesize different glycosides using those. And yesterday we have considered as a starting compound the most stable chair conformation form of the D-glucose, and that is a cyclic form. It is present in alpha or beta. We have considered here that anomeric hydroxyl group present at one position or carbon number 1, you can call it as a anomeric carbon atom. Anomers means what? It is a diastereomer. They differ in the configuration only at one carbon atom, C1 carbon atom, and that type of the optical isomers are known as anomers. And then that anomer we have taken as a alpha or beta, that type of the mixture, or we can consider as it is. Then first one, if you observe this structure, there are one reaction site, one primary alcoholic group is present, that is a CH2OH. Then 3 secondary alcoholic groups are present, and the one is anomeric. So these are the 3 sites of reaction which are actually present in the chair conformation, or what we can call it as a cyclic ring of the D-glucose. And when first it is treated with, suppose these reactions are carried out with acetic anhydride in presence of base like as a sodium acetate, the acetylations are slower down. Instead of sodium acetate, if you use as a Lewis acid catalytic amount, there is a that reactions are rate of reaction are increased over the previous one, and therefore, and once you acetylate acetylation occur, all the hydroxyl group primary as well as the secondary and the anomeric hydroxyl group all are first one when it is treated with acetic anhydride in presence of the Lewis acid. Within a few minutes the acetylation takes place with the primary alcohol. Acetylation occur or the observe at that primary hydroxyl group, and if you use as a excess amount of acetic anhydride in presence of the Lewis acid, you will end up with all the hydroxyl group, primary hydroxyl group, secondary hydroxyl group and the anomeric hydroxyl group all get replaced by the acetylation group, and this acetylation with the reaction controlled condition, the anomeric acetyl group selectively converted into the alpha bromo glycosides or the glycoside bromide, alpha form of that is obtained when this compound, this acetyl derivative treated with the hydrogen bromide, and it will end up with the more selectively, specifically we are getting as a alpha bromo glycoside derivative, and this derivative it act as a donor, and when it is further treated with some other reagents, so maybe as a thiols, it may be as a thiol, so it will be converted into some other derivative or reduction or free radical reaction also occur, and you will end up with the carbon-carbon bond formation. So these are the things we have discussed yesterday. Today what you are going to learn, today we are going to learn very important or the prominent or significant concept we are going to learn, that is by using donor acceptor concept, that is a thioglycosides, that is a thioglycosides which we are considering here. Thioglycosides, this is a point which we are discussing today, and it is a very important as far as exam point of view is concerned, or this topic is concerned, or this course is concerned. And this is we are going to learn with the help of donor acceptor concept. Thioglycosides, when it act as a donor, when it act as a acceptor, that type of the thing we are going to learn, we are going to discuss here right now. So first of all, let's see what do you mean by the thioglycosides. Thio clearly indicate that they are sulfur atoms are containing compounds are known as a thio, and glycoside, as we know that glycosides are the derivatives of that D-glucose, and so that's why we are going to learn the thioglycosides. Now thioglycosides are not vary in nature, only a few simple alkyl or aryl thioglycosides have been found as constituent of antibiotics from streptomycin species, although not readily thioglycosides, glucosinolates with an anomeric sulfur are also well-known natural compounds. In spite of their low natural abundance, thioglycosides and their chemistry have for a long time been a field of interest for many researchers. The first thioglycoside was synthesized in 1909 and their basic chemistry was early reviewed. But it is only recently that their excellent glycosyl donor qualities have been recognized. In the beginning of the 17th, the first successful synthesis of a disaccharide was performed, but it was not until the middle of the 80s that enough efficient promoters were discovered to make glycosylation with thioglycoside donors into a general and accepted method. Since then, and in a very short time span, thioglycosides have become one of the most used type of donors, especially in glycosylation with oligosaccharides donors, that is a block synthesis. And there are already some reviews on the subject, and in the most recent complete list of published glycosylation during 1 year 1994, thioglycosides were used as a donor in about 20% of all reported glycosylation and in 35% of all coupling using oligosaccharides donors, competing well with the long established halide donors and the trichloroacetamidates method. The strength of thioglycoside as a glycosyl donors is their easy synthesis combined with their stability withstanding most reaction conditions used in, for example, protecting group manipulation and glycosylation, and at the same time their effective activation using chemoselective thiophilic promoters and also easy transformation into other types of glycosyl donors. Hence, they are perfectly fitted to be used in block synthesis of oligosaccharides, where stable oligosaccharides donor are a prerequisite. Their stability also makes them very apt in synthetic schemes where a number of chemical modifications are performed just prior to the glycosylation, as for example in various types of internal glycosylation. In this article, the synthesis of thioglycosides and their activation and application as glycosyl donor are discussed. Synthesis of thioglycosides. Now we are talking about the synthesis of thioglycosides. Synthesis of thioglycosides. Obviously, one important feature of attractive glycosyl donor are their easy availability. The synthesis of the most used type of thioglycoside donor, mainly simple alkyl or aryl glycoside, is straightforward and can be performed as a large scale using cheap chemicals. Often the product is crystalline and can be purified without chromatography. Numerous ways to prepare thioglycosides have been described, but for the easy production of thioglycosides, mainly two synthetic methods are commonly employed, namely the reaction of peracetylated glycose with a thiol in the presence of Lewis acid, and the reaction of an acylated glycosyl halide with a thiolate. And now is from anomeric acetate. Now from the anomeric acetate. From anomeric acetate. From the anomeric acetate, how we can obtain these glycosides that we are discussing right now. As depicted in scheme first, let us see that scheme over here. And what is that scheme? From anomeric acetate, let me draw that scheme. This is a very simplest to draw, chair conformation, and now all these are protected acetyl group which are lying at equatorial position, and here we get equatorial, all are equatorial position. This is the glycoside, protected glucose it is, and when it is treated with the simplest ethyl thiol, ETSH, it is also called as a mercaptan, and this ethyl thiol, the solvent used as BF3 ET twice O, that is a trifluoroboron etherate in presence of CH2Cl2 dichloromethane. The yield obtained is near about 83%, and the product which we are getting over here, due to the rearrangement or the what we can call it as a neighboring group participation, due to the presence of acetyl group, you will end up the product is as it is at a beta position. We are going to get SET over here, this type of the thioglycosides. This is the first thioglycoside was synthesized here in this manner by using this. Everything is the same, only that OAC acetyl group get replaced by this thiol, and which is obtained from anomeric acetate. And anomer, as we know that alpha and the beta ring structure of the D-glucose is known as anomers of each other. They are the diastereomers, and they differ in configuration at only one C1 carbon atom. That type of the optical isomers are known as anomers, and this will be the scheme number first over here. It's a scheme number first I am representing over here, and so simple. Just we have treated this with that ethyl thiol, and this is a solvent used there, and we are getting as a end up with the beta anomers. As depicted in scheme first, an anomeric acetate is usually easily substituted or displaced with thiol under Lewis acid promotion to give thioglycosides, and that is one of the thioglycoside is synthesized by using, this is one of the simplest method to obtain, to derive the thioglycosides. Okay. A standard procedure is to react per-acetylated aldose dissolve in dichloromethane CH2Cl2, or chloroform you can use with a slight excess of thiol using a hard Lewis acid, for example trifluoroetherate or FeCl3, or we can use as a FeCl3, that is a ferric chloride, or you can call it as a trichloroferrate, ferric. As a promoter, this is act as a promoter to give high yield of the 1,2 trans product, that is a neighboring group participation. Beta acetate precursors usually, this is a beta acetate precursor. Beta acetate precursors usually react faster, which is an advantage since this diminishes the formation of 1,2-cis impurities through Lewis acid catalyze anomerization of the beta thioglycosides. Alpha beta mixtures are often obtained with less reactive percaptons or glycosyl acetates. Variation of this method include the utilization of trialkyl stanyl or silyl derivatives of the mercaptan. Advantages are less order and sometimes higher yield owing to less formation of 1,2-cis and dithioacetal side product. Disadvantages are the accessibility and cost of the reagent. Also, thioacetic acid can be used as a nucleophile. In this approach, to give anomeric thioacetates, which in a two-step product can be selectively deacetylated alkylated to give thioglycosides, a sequence often used in the synthesis of thioglycosides. So, how it is obtained? That is a Thioglycosides, it is represented over here. RSH is called as a mercaptan, or it is a sometime it may be aryl or alkyl thiol from glycosyl halides. And now we are talking about from glycosyl halides. Let us see over here how we can obtain that from glycosyl halides. Next point, we are talking from glycosyl halides. Let's see here. This is a classical way. This is a classical way to thioglycoside, in which an acetylated glycosyl halide is reacted with a thiolate in a polar solvent to yield the 1,2-trans thioglycoside, that is the scheme number 2nd. Let me show you here from glycosyl halides. Let us see the structure of glycosyl halide. Over here I am representing the structure over here. So all are hydroxyl group which are lying at equatorial position. Hydroxyl group get replaced by the acetyl group. I am showing they are as it is. Now at a alpha position, this is a alpha glycosyl halides. Alpha glycosyl halides suitably treated with the thiolates pH Na, that is the thiolate, positive and negative charge over there. Thiolate, it is treated in presence of Et twice ether in presence of water, and the yield is obtained near about 84%. Now look at here, this beta is below the plane, therefore alpha glycosyl halide it is. Alpha, this is the alpha glycosyl halide. This is one of the glycoside, alpha glycosyl halide. When treated with thiolate, this is known as a thiolate, just like as acetate. So we can replace that oxygen by sulfur, and therefore we can call it as a thiolate. And that thiolate, the solvent used as a here ether in presence of water, that is a polar solvent. And as we know that polar solvent means what? The solvent which is differ in the electronegativity, or they can exhibit, they can show the dipole moment. So that type of the compound are known as a polar compound. And the reactions are carrying out. If you observe this reaction carefully, what do you observe over here? Look at here. The reaction carried out similar to as a SN2 type reaction. Have you heard about that SN2 type? SN2, yes, indicate as a substitution, or we can call it as a displacement. N is called as a nucleophile and 2 for the bimolecular. But it is and where the product is obtained as an inverted product. If you remember the SN2 reaction, it is a concerted reaction. Concerted reaction means what? The bond breaking and bond making takes place simultaneously, and that type of the process is called as a concerted process. And this SN2 reaction is an inverted product means what? The nucleophile attack from the back side always, and the product obtained is a completely inversion product. Suppose if you start with the optically active substrate, if your substrate has a R configuration, and when the product is obtained, it must have a S configuration, and so that type of the reaction is called as a SN2 type of the reaction. Same reaction is occurred over there, and here the thiol, the substituent is acquired at a equatorial position, and that becomes as a very stable one, SPH over there. That is a thioglycoside we are obtained starting from the glycosyl halides. So that is one of the important thing you should remember over here. You have obtained, or you derived, or you can derive the thioglycoside from the glycosyl halides. That's it. And now here you can write ACO, then OAC, and now here is the OAC. So this is the simplest one. So as we know that this is one of the structure which we got over here. This is a alpha glycosyl halide. This one is alpha glycosyl halide, and from that you are getting as a beta thioglycosides, beta thioglycosides, because this is present at beta side, and therefore it is known as a beta thioglycosides, and it is obtained near about, the yield is 84%, very high yield, and therefore it is important. And both alkyl and aryl mercaptans, and you know that mercaptan means RSH is known as a mercaptans, and this R may be as a aryl or alkyl group, thiol. Aryl or alkyl thiol is known as a mercaptan, so remember that one. And both alkyl and aryl mercaptans have been used, and good yields are usually obtained, although especially with the more basic alkyl thiolates, reacetylation step is often necessary prior to workup and isolation of the product. If controlled condition and an aprotic polar solvent, aprotic means what? Where there is no hydrogen atoms are present, and that type of the solvent is known as a polar protic. Polar means that can show, or that can exhibit as a, what we can call it as a it can show the dipole moment. So that type of the reactions are over there, and displace SN2 type displacement. Just now I told you that SN2 type reaction means what? The SN2 reaction has some significant or prominent characteristic. They are the SN2 means substitution nucleophilic bimolecular reaction. Number second, it is a bimolecular. Rate of reaction found to be depend upon the concentration of the substrate as well as the nucleophile. And second thing, nucleophile always attack from the backside. And third important point, when the nucleophile approaching from the backside, the resulting compound is always in a inverted form, and it is a second order reaction, it is a concerted reaction. So these are the some of the important or the prominent or the significant point you should remember as far as SN2 type of the reactions are concerned. So I think this is enough for these lectures. In the next lecture, tomorrow's lectures, we will learn, we will discuss about the glycosyl halides by using that as a starting material and how we can derive different thioglycosides and how they can act as a donor in the further synthesis of the glycosides or the oligosaccharides or in the polysaccharides, or sometimes that thioglycosides, how it is acted as an acceptor also in some cases, how donor and acceptor both the role played by that thioglycosides, how they are playing. Donor is no doubt we have seen just now, but how it can act as an acceptor also in some cases, and how the stereoselective reaction or anomeric controlled reaction, high yielding product, why it produce. This type of the discussion we will discuss in the next lecture. I think with this, let us stop today here. Remaining we will see in the next lecture. Thank you. Have a nice day.